Hare Krishna. So student, this is my 7th video and the second video of the inverse trigonometric function. In the first video of the inverse trigonometric function, we have studied the theorem and the 6th proposition. In the 6th proposition, we have proved the formulas, that is the derivative of a sin inverse x, derivative of a cos inverse x, derivative of a tan inverse x, derivative of a cot inverse x, derivative of a sec inverse x, and derivative of a cosec inverse x. And in the last video, that is the video of the inverse trigonometric function, we have studied also the examples on what here the derivative of a sin inverse x. We have studied there 5 examples, isn't it? In the different type of examples on the sin inverse x, variety of a problems we have taken on sin inverse x. The ddx of sin inverse x, that is equal to 1 upon root of 1 minus x square. Now today I am continuing this, that is the inverse trigonometric function. So the second formula, that is ddx of cos inverse of x. The derivative of a cos inverse of x, that is minus 1 upon root of 1 minus x square. See, again take the simple problem, ddx of cos inverse of 3x plus 2. Second one, ddx of cos inverse of log x. Again, ddx of cos inverse of a raised to x. Fourth one, ddx of cos inverse of sine of 5x square plus 3. Again, fifth one, ddx of cos of sec inverse of 1 upon tan of e raised to x. Here again, ddx of cos inverse of 1 upon x cube. Isn't it? So I have given the 6th problem. Again see how you have to do this. Here again we have to apply the chain rule. So the student, that is the first one, ddx of cos inverse 3x plus 2. Right? Again this 3x plus 2 considered as a u. The derivative of a cos inverse u, again minus 1 upon root of 1 minus u square. Isn't it? That is minus 1 upon root of 1 minus u square. What is u? 3x plus 2. That you have to write 3x plus 2 whole square. Right? You have substituted u and find it the derivative. Again you have to find out the derivative of a whatever the u you have substituted, that is ddx of 3x plus 2. Right? Now again if you observe this, minus 1 remain as it is. What is the derivative of a 3x? That is 3, and divided by 1 minus 3x plus 2 whole square. Now you can simplify also. It is not necessary. If you simplify, then you will get this here. A plus b whole square means the square of a first term. Twice the multiplication of a 2 term. 2 2s are 4, 4 3s are 12, 12x. And this is nothing but what here? 4. Again, if you observe this, this is root of 1 minus 9x square minus 12x minus 4, isn't it? Minus 3 divided by, here you have got minus 9x square minus 12x and minus 4 plus 1, that is equal to minus 3. This is the final result. Up to this also you can do that, right? Up to this also you can solve the problem, or further you have to simplify, then you can simplify like this also, right? And that is depend upon whatever the results given in the entrance, whatever the options given in the entrance, right? So in that way you can simplify the function, right? Now I will take a second one. See, that is again very simple, ddx of cos inverse of log x. Right? See here again. Very simple. Here again you have to substitute u. What is the derivative of a cos inverse u? That is minus 1 upon root of 1 minus u square. U means log x whole square. And d dx of what? Log x. What is the derivative of a log x? That is here again square 1 minus log x whole square. And what is the derivative of a log x? That is 1 by x. Very simple here. Second one. That is third one. See, d dx of cos inverse of a raised to x. Again a raised to x you have to consider it as a u. The derivative of a cos inverse u minus 1 upon root of 1 minus u square means a raised to x whole square, and d dx of again a raised to x. So what is the derivative of a raised to x? The derivative of a raised to x, that is a raised to x log a divided by root of 1 minus a raised to 2x. Power, it is multiplied to the power. That is about the third one. Now again take here the fourth one. See, d dx of cos inverse of sine of 5x square plus 3. Again if you observe this, suppose you substituted u, isn't it? Suppose you directly try to apply the chain rule, then what happens here? If you substitute u, again minus 1 upon root of 1 minus u square means you have to make the square of this. Again you have to take the derivative of this function, that is sine u, cos of 5x square plus 3. Again you have to find out the derivative of a 5x square. Now you can reduce the function. Since there is a cos inverse, that sine you can convert in the form of a cos by taking the help of a pi by 2. You know the sine of pi by 2 minus theta, that is equal to cos theta. Therefore this you can write as a d dx of cos inverse of this sine you can write as a cos of pi by 2 minus theta. What is theta here? 5x square plus 3. Right? This is your theta. See. Again you know cos inverse cos get cancel. What is remain? Pi by 2. Multiply with minus sign and open the bracket. Minus 5x square minus 3. Right? Now it is quite easy. Again the derivative of a pi by 2, that is 0. Minus 5 remain as it is. When the constant, it is multiplied to the function, constant remain as it is, and again you can take the derivative of a x square, that is equal to 2x. And here again the derivative of a minus 3, that is totally constant and it is equal to 0. Therefore your result, it is minus 10x. So it is quite easy. If you directly apply the chain rule, then you have to substitute u, cos inverse u 1 upon root of 1 minus u square, again sine square in the form of a root. Again you have to take the derivative of a sine u means cos of 5x square plus 3, and the derivative of a 5x square, that is equal to 10x. That is too lengthy, and answer it is also not given in the options of the MCQs, isn't it? Therefore what you have to do, that sine you have to convert in the form of a cos, right? So sine you can convert in the form of a cos by taking the help of a pi by 2, because sine of pi by 2 minus theta, it is always equal to cos theta. Therefore this angle you can write as a cos of pi by 2 minus 5x square plus 3, right? Again cos inverse